Welcome to Engineering Science Info. Today we'll be looking at dynamics. We'll be looking at the April 2021 past exam paper, and we'll be looking at part 2. So part 2 deals with accelerating forces on the vertical motion, and that will be question 4.2. Let us take a look at the question. So the question reads as follows: that a bucket of cement with a mass of 3.5 kilograms is hoisted up to a height of 45 meters. It accelerates with an acceleration of 1.6 meters per second squared. Calculating number 1, the force that is needed to accelerate the bucket upwards. Question number 2, calculate the work that is done. Let us now take a look at the solution. Let us first analyze the statement and look at the given information. So first of all, if I read the statement, first of all, I'm given a mass. The mass here is 35 kilograms. The symbol which we use for mass is the letter M. Next, it is telling us that it is hoisted up a height of 45 meters. The symbol for height is H and it is in meters. Next, we have very important direction, and we know that the question is going up. So the bucket of cement is moving upwards. Lastly, we have acceleration. The symbol for acceleration is A, and it is 1.6 meters per second squared. Right. Let's now use the given information to draw a diagram. Okay. So this is the bucket of cement, and for the cement to go up, it requires an applied force. Okay. So the applied force needs to pull the bucket up. It needs to move in the direction that it wants to go. Since the bucket has a mass, okay, the force of gravity is going to be acting on this bucket, and we know that the force of gravity acts downwards. That is why we have weight is equal to mg. So weight is calculated as mass times your gravitational force. Now let's look at the solution to calculate the force that is applied upwards for the upwards acceleration. So if I look at the given information according to my diagram that is shown here, we need to understand what is the formula we're going to use. So number 1, this bucket of cement is accelerating. So we need to use the Newton's law formula. Accelerating forces is applied minus the weight. So why are we saying the applied force minus the weight? Because number 1, when we look, the force applied is going up, the weight is going down, which means these two forces are moving in the opposite direction. When forces or vectors move in the opposite direction, we do not add, we subtract. So how do we determine which force is bigger? Number 1, we need to look at the way in which the object wants to go. The object wants to go up. In order for the object to go up, it means the applied force needs to be bigger than the weight. So since the applied force is bigger than the weight, the formula is now going to be accelerating forces is equal to applied force minus the weights. Accelerating force is calculated as mass times acceleration. The applied force is what I'm calculating, and the weight is calculated as mass times gravity. Let's substitute our values. The mass is 35, acceleration is 1.6. The applied force is what I'm finding. Again, the mass is 35 and the force of gravity is 9.8. So I need to make applied force the subject of the formula. To make applied force the subject of the formula, I need to take these values here for mg over onto the other side. When I do that, the sign is going to change from negative to positive. So now the applied force is simply calculated as 35 times 1.6, which is my accelerating force, plus 35 times 9.8. So the force applied is going to be 399 newtons. Right. So very simply what we need to do in a question like this is, remember, we need to draw a diagram. The applied force will always move up, the weight will always move down. We look at which force needs to be bigger in order for the object to move in that direction. In this case, because the bucket wants to move upwards, the applied force needs to be greater than the weight. So the applied force is the one going upwards, so the applied force needs to be bigger, so the bucket goes up. That is why the formula reads accelerating force is applied minus my weights. Next question. Let us calculate the work done. So if I look at the formula for work done, the formula for work done is simply going to read force times distance. So when I look at the distance, distance can either be represented vertically or distance can either be represented horizontally. If I look according to my question, the bucket is moving a height of 45 meters. So from the ground to the top, it moves a vertical distance of 45 meters. So here we can use the vertical distance in order to calculate the work done. So in order for work to be done, the force needs to cause the object to move over a certain distance. So my force that I have is the applied force of 399, and the distance that is moving is now a vertical distance of 45. So the work done here is going to be 17,955 joules. Thank you for watching today's lesson.